Hello. Hello. We're in Algebra 2. This is Chapter 7, Section 1. We're on page 4 of the notes. We have some examples about compound interest and then a checkpoint using compound interest and exponential growth. Good times. Okay, so example 4. Find the balance in an account. Now, it says you deposit $2,900 in an account that pays 3.5% annual interest. Find the balance after 1 year if the interest is compounded monthly and annually. All right, so first of all, just in terms of structure of the problem, you'll notice that they ask you two things, one monthly, one annually. That's two different questions. And in the answers, they've set it up. So monthly is part A and annually is part B. And I say that because I'm going to highlight all the other aspects of that information as well. You deposit $2,900. Boom. That's P. That's the principal. That's the initial amount you have. In an account that pays 3.5% annual interest. Boom. 3.5% annual interest means we have to be slightly careful here because it means that R equals, and we have to move that percent into normal decimal form, 0.035. Take the percent, move the decimal over twice. Boom, you've got an actual number to work with. Find the balance after 1 year. So 1 year, boom, that is our value for T. Boom, T is 1. And then in part A, when it asks for monthly, that means that N equals 12. And that's because there are 12 months in a year. So here we go. We have the formula, and they didn't write it down for us. That seems kind of not nice, so I'm going to write it down for us. A equals P in parentheses 1 plus R over N to the NT. This is how all exponential numbers work here. And so A equals 2,900. That's the P. So I'm just going to write that there. And then boom, parentheses 1 plus R is 0.035 over 12. End parentheses to the 12 times, and then T. T is 1 in this case because they asked about 1 year. Now, I want to encourage you all to be careful, and in the exponent, I suggest putting it in parentheses also, and that's because of the way you all tend to use your calculators, and putting that in parentheses will help you get the right number out of your calculator. So we're talking about 2,900, and then if you combine the stuff in the parentheses there, it's 1.0029-ish to the 12th, and that's what you get by doing 12 times 1. And then approximately that's $3,002.55. Rounded to the nearest cent. So that's the balance at the end of 1 year. Boom, make it money. $3,002.55. That's the amount after 1 year if the interest rate is 3.5%, and they divide that interest into 12 pieces. All right. Now, part B, annually. Same formula. The only difference this time is that when they compound it annually, boom, that means that N equals 1. And that's because, well, it's only happening once a year. So 2,900 times 1 plus 0.035 over 12 to the 1 times 1. N is 1, T is 1, and again I recommend you put this in parentheses. So it's 2,900 Oh, you know what? I made a mistake. The denominator here should not be 12. It should be 1 because it's compounding once. On to the next line. 2,900 times 1.035 to the 1, and that gives us about 3,001.50. So the balance at the end of 1 year is approximately $3,001.50. All right. Different numbers because in the first case they gave you less interest but more often, and then when you earned interest later, it included the interest you had earned before, and that happened repeatedly over the course of the year. In the second case, they gave you more interest but all at once, and you didn't have a chance to earn the interest on the interest from before. Let's move on to the checkpoint. It says, from example 3, how many buffalo were in the park after 11 years? Oh, goodness. Okay, so we know from before that there's a formula for the amount of buffalo in the park. And that is that, oops, wrong letter, sorry. N equals 38 because the park began with 38 buffalo, and then 1.07 to the T. However, because it's 11 years, we're ready to rock and roll and say N equals 38 times 1.07 to the 11. And if you evaluate that on your calculator, you'll get that N is approximately 80. Give or take a piece of buffalo. But 80 to the nearest buffalo. Boom. That's our answer for that part of the checkpoint. Pretty fast there. You had a formula already established, plugging in one number, ready to move forward. Number 3 on this checkpoint is a little bit more involved, but it's actually much more valuable. We need to read this information and then get the right variables assigned with the information, and then use that general compound interest formula. It says you deposit $5,000 into an account that pays 3.72% annual interest. Find the balance after 3 years if your interest is compounded quarterly. Okay, so boom, you deposit $5,000. P equals 5,000. Pays 3.72% annual interest. R equals 0.037, and wrong number there, 2. Boom. Find the balance after 3 years. Aha! T equals 3. If the interest is compounded quarterly, oh goodness, quarterly, that means it happens 4 times a year. And since it's compounded quarterly, that means N equals 4. Now we can take all of this information and move forward, because we know that A equals P times 1 plus R over N to the NT. So A equals, and our P is 5,000, times 1 plus, and our R is 0.0372 over N, and is 4 quarterly, to the 4 times 3. And as before, I recommend you put these in parentheses to make sure that it goes out pretty well. Now, you can spend your time simplifying this if you want into little pieces, but you all have calculators that can just do it all in one swell swoop. So A is 5587. Let's see, my calculator says, and 45 cents. So it's about $5,587 and 45 cents. That's how much money if you're given a small amount of interest 4 times a year at that rate for 3 years if you started with $5,000. Thank you for watching.